Hello there, Mr. Sutton here, bringing you the IM3 Honors 5-3 Extra Practice number 6 solutions. This one has a puzzle that goes with it. Let's take a look at that. For this puzzle, we're trying to solve the riddle, what do skeletons say before dinner? We have to find the roots of each of these polynomials, and they're not giving us any of the roots, so we have to generate those from scratch using the true rational roots theorem. Once we find those roots, we locate them over here on the right, and cross out the letter down below that goes with those answers. The letters that are left over will spell out the answer. So let's give it a shot. So here's our opening problem. We have x cubed minus 6x squared plus 11x minus 6. And if we're double checking, the ratios of the first two terms and the last two terms are not the same, so you couldn't even use grouping on this if you wanted to. So let's generate our list of rational roots. Since we have a lead coefficient of 1, we really just have to worry about the constants factors here. So factors of 6, we've got 1, 2, 3, and then 6, and that's it. So my strategy is I'm going to plug all of these into this polynomial using my calculator until I find one that actually works. Then I will use that with synthetic division to break it down, get the quotient, and go from there. So let me plug this in my calculator. Since this is our first problem, I'm going to show you some things in slow motion. Then I'll just do a little bit more off camera on future problems. So I'm going to go to y equals to plug all of this in. And there's my x button right there. And my exponent button. And I can just go from there. So we got minus 6x squared plus 11x minus 6. Now to plug things into this quickly, if I'm plugging in a bunch of things, I'm going to quit out of there, and I'm going to go to second table set, and then for this independent part, I'm going to switch that over to ask. So instead of generating all the different x values that I'm plugging into my function, automatically it will ask me for the x values, and I can choose whatever I want, even if I have things that are not right next to each other. So now I'm going to go to second graph to get table, and I'll start plugging in these different possible rational roots until I get 0 over on the other side here. So let me start with 1, and if I press enter, that gives me 0. So right off the bat, I found a rational root. If that didn't work, I would have tried -1 and then 2 and -2. I like to alternate back and forth between the positive and the negative, just so I'm going to be working with as small a number as possible when it comes time to do the synthetic division. But 1 works, so I'm going to write down here that f of 1 was 0, just so people know where I'm getting this from. And now let me do synthetic division on this using 1 as my box number. So we've got coefficients of 1, -6, 11, and -6, box number of 1. Bring down the 1. 1 times that is 1, plus -6 is -5, times 1 is -5, plus 11 is 6, times 1 rather is +6, all of which adds up to 1, which is what we were hoping for. So I've got x minus 1, the factor that this 1 here gives me, and I can also break this down into the quotient. This is 1x squared minus 5x plus 6. All of that equals 0. I can factor this stuff here, so I've still got that x minus 1, and now here I'm looking for factors of 6 that add up to -5. So 1 and 6 doesn't work, but 2 and 3 does if they're both negative. So x minus 2, x minus 3. Now I will take each of these factors, set them equal to 0, and solve. So we've got 1, and x equals 2, because 2 minus 2 is 0, and x equals 3. Oh, that's poetic. 1, 2, 3. So let me find those answers. That's choice C right here. So let me find the C down below, and I'll cross that off. Now, one thing I do have to be a little bit careful about with these letters, some of them are repeats, like I see multiple E's there. So I do have to be ready to cross off more than one. This time, though, there was only one C. So on we go to the next. Next up, my second problem. Here is another one of those. Now this one, if you look at the ratios, this is 1 to 5 and also 1 to 5 for the first two and the last two terms. So you actually could use grouping on this, but I'll use rational roots because this is all about rational roots in this puzzle, just to show you how it works. So let me get my possible rational roots. Again, we have a lead coefficient of just 1, so I'm going to get my factors of my constant and just divide all those by 1, so I don't really have to worry about that. So I'm looking at factors of 20. We've got 1, of course, and then 2 goes into 20, and 4, and then 5, and then it's 2 times 10 is the next one, and of course 1 times 20 was the other one. So now let me start plugging those in my calculator. So off camera, I entered my polynomial here into my y equals. And now I'll just go ahead back to table and start plugging in these numbers till I get something that works. So we got 1, that doesn't work. -1 gives me -12. Let me try 2. That gives me 0. So I tried a few things. F of 2 gave me 0. So let me go ahead and use that with synthetic division. So we've got 1 for my first coefficient, and then 5, -4, -20. Box number of 2 this time. Bring down the 1, times 2 is 2, plus 5 is 7, times 2 is 14, plus -4 is 10, times 2 is going to be -20, zeros out. So I've got x minus the 2 that I took out initially, and then this is 1x squared plus 7x plus 10. Can bring down that x minus 2, and now for this one, I need factors of 10 that add up to 7. 1 and 10 doesn't work, but 2 and 5 does, both positive. So x plus 2, x plus 5. Zeroing each of these out, I end up with x equals +2, -2, and -5. And I see all that with choice D right here, so let me cross off the first D I see, and that's just one of those right here. All right, we're on to number 3 now. So let me look at my factors of my constant, 24, and again, lead coefficient of 1, so not worrying about turning these into fractions. So we've got 1, 2 goes into 24, so does 3, and 4. 4 times 6, 3 times 8, 2 times 12, and then 1 times 24. Time to plug these in the calculator. So here I am on the calculator. I just entered my polynomial into my y equals for y1. Let me go to table and start plugging in some of these numbers. So plugging in 1 gives me 10. -1 gives me a value of 36. 2 gives me 0. Nice. On the third try. So these 1 and -1 didn't work out, but 2 gave me 0. So let me use synthetic division with 2. So we got coefficients of 1, -1, -14, and 24. Box number of 2. Bring down our 1 times 2 gives me 2, plus -1 gives me 1, times 2 gives me 2, plus -14 is -12, times 2 is -24, which cancels out. I have x minus the 2 that I found initially. Then I have 1x squared plus 1x minus 12. So let's bring this x minus 2 down a little further and factor the rest of this. I need factors of -12 that add up to 1. Let's see, 1 and 12 doesn't work, 2 and 6 won't work. 3 and 4 works if I have -3 and +4. So x minus 3, x plus 4. And then zeroing all of those out, we have x equals 2, 3, and -4. So 2, 3, -4, I see all of those together with m. So cross off the m there, and that's the only m. So on we go. All right, moving on to number 4. Things are about to get a little extra spicy on these problems because you'll notice we now have a lead coefficient here that is not 1. So that means I can't just look at the factors of this last constant anymore for my PRR list, possible rational roots list. I also have to take all those factors and divide them by all the factors of this lead coefficient 3. So I'm going to have plus or minus factors of 35, which is 1, 5, and then 5 times 7 and 1 times 35, all those, over factors of 3, which granted there's not that many, there's just 1 and 3. So now I have all of these numbers up here divided by 1. So 1, 5, 7, and 35 are by themselves possible rational roots. And then all these numbers divided by 3. So 1/3, 5/3, 7/3, 35/3. So these are all the things I'm going to potentially have to plug in. I might have to plug in some fractions to make something work, but I'm hoping I get a hit before I get to those. So I'll do those after I've tried all these other ones, because those are a pain to do with synthetic division. All right, to the calculator. So there we are. I've just plugged this crazy polynomial into my y1. Let's go to our table now where I've already got the independent ask option set up. Go back to problem 1 and check out that part of the video if you want to see how I did that. So let me try the ones first. So positive 1, plugging that in. Negative 64, that doesn't work. Let me try negative 1. 144, that doesn't work. Let me try positive 5. That gives me a 0, thankfully. So 1 and negative 1, no dice, but 5 gives me a 0. So we've got coefficients of 3, 5, negative 107, and 35, plugging in a box number of 5. So we bring down our 3 this time, times 5 is 15, plus 5 is 20, times 5 is 100, plus negative 107 is negative 7, times 5 is negative 35, and that zeroes out. So I have an x minus 5. I also have a 3x squared plus 20x minus 7. So I'm going to need to use some kind of advanced factoring technique, either guess and check or the AC method. I'm actually going to go with the AC method for factoring this down further. That's assuming it can be factored. I guess I'll figure that out once I look at the AC value. So we have 3 times negative 7 for an AC of negative 21. So I'm looking for factors of negative 21 that add up to 20. I'm pretty sure I can pull this off. If I have 1 and 21, negative 1 and positive 21, that would work. So let me split this up. I'll have 3x squared minus 1x plus 21x minus 7. Now for my first two terms, I can take out an x, leaving me with 3x minus 1. Next two terms, I can take out a 7. Leaves me with a 3x and a minus 1 there as well. So for my factors, I have the x minus 5 that I took out initially, and now I have this 3x minus 1 common factor that I can take out of all that stuff, along with the x plus 7 that's left over. Zeroing each of these out, I end up with x equals 5, and for this next one I have to add 1 and divide by 3, so 1 over 3, and then finally negative 7. So 5, 1/3, negative 7. I see all those right here with y. So let's cross off this y right here, and I think that's the only y, so we're on to the next problem. For this one, we have a lead coefficient that again is not 1, so we're going to have to use the full rational roots theorem here. I need factors of 9 over factors of 6. So this is going to be plus or minus. For the 9, we've got 1, 3, and 9. Those are the only 3 factors there. For 6, we actually have some more. We've got 1, we've got 2, 3, and 6. So just being methodical about this, I've got all of these numbers in the numerator over 1. So 1, 3, and 9 plus or minus. Those are rational roots. Next up, I've got all of these numbers up here over 2. So 1/2, 3/2, 9/2. Next up, I've got all these numbers over 3. So 1 over 3 and 3 over 3, but that's just 1, so I don't need to write that again. And then 9 over 3 is just 3, so again, don't need to write it again. Finally, we have all these numbers over 6. So 1 over 6, 3 over 6 is just 1/2, which I've already got written, and 9 over 6 is just 3/2, which again I've already got. So these are all of our unique rational roots. No need to try something more than once. Let me try all these out in my calculator now, or at least as many as it takes to get a 0. So there's my y1. I've entered all of this into my y equals there. Going back to the table again, let's try our traditional beginning of 1. which doesn't work, and -1, which doesn't work. We were trying to get a 0 here. Next up, we've got 3, which gives us a 0. So I keep getting it on the third try. Wow, this is almost getting predictable. But you never know. You gotta play it honest on these. So let me see here. I tried 1 and -1. None of that worked, but 3 worked. So writing out my coefficients for synthetic division, we've got 6, -11, -24, and 9. And then 3 worked, so we'll use 3 for my box number. Bring down the 6 times 3 is a positive 18. Plus -11 is 7. Times 3 is 21. Plus -24 is -3. Times 3 is -9. All that adds up to 0. So we have x minus 3, 6x squared plus 7x minus 3. Let's see here. I am thinking AC method might be worth trying here. So we have an AC value of 6 times -3, -18. Factors of -18 that add up to 7. Let's see, 1 and 18 is no good. 2 and 9 works if it's -2 and positive 9. So we've got 6x squared minus 2x plus 9x minus 3. For my first two terms, I can take out a 2x, leaving me with 3x minus 1. For the next two, I can take out a 3, leaving me with 3x minus 1. So I've got the x minus 3 I took out earlier. I've now got a 3x minus 1 that I can take out as a common factor. And then I have my leftovers of 2x plus 3 as well. Zeroing each of these out, we've got 3. This next one is going to be a positive 1 divided by 3. And lastly, we have a minus 3 over 2. So 3 1/3 -3 halves. I think that's right here. 3 1/3 -3 halves. Yep, it's u. It had to be u. So we'll cross that one off. Moving on to number 6 here. You might be thinking something's a little suspicious because they threw a bunch of them at us with lead coefficients that were not 1, and now all of a sudden we're back to 1x cubed. And in fact, if you look a little closer at this problem, we have a 1-to-3 ratio for the first two terms, and 4/12 is a 1-to-3 ratio for the next two. So you actually could solve this one by grouping if you wanted to. I will use rational roots, again, just to be consistent with my method, but grouping would be a lot faster than what I'm about to do. So here we go. We need factors of 12 now over 1, which is just to say factors of 12. So we've got 1, 2, 3, 4, and then we had, let's see here, 2 times 6 and 1 times 12. That's the other ones. Let's plug all these in the calculator. So here I am on the calculator. I've plugged my polynomial into y1. Going to second table, trying some things out. Let's start with the 1s. We got 1 doesn't work. -1 gives me 10. Let's go on to the 2s now. 2 doesn't work. This is the first time in a while the third thing I tried hasn't worked. Let's try -2. That gives us 8. All right, well, let's try the 3s. +3? Nope, that's 78. -3. That's 0. Okay, I was starting to get a little nervous, but after 6 tries, we finally found something that worked. So 1, -1, 2, -2, 3, and finally -3. We tried all of them and finally got one that worked. So let me use synthetic division on -3. We have coefficients of 1, 3, 4, and 12. Box number of -3. Bring down the 1. Times -3 is -3. Plus 3 is 0. Times -3 is still 0. Plus 4 is 4. Times -3 is -12. Plus 12 is 0. So we have the x plus 3 that we took out. We have the x squared, and there's no x term. This is just 0x right here. So just plus 4. So to do this one, I can set x plus 3 equal to 0 and solve it. So that's just going to be -3. And I can set x squared plus 4 equal to 0. So I can write x squared minus 4, or equals -4. And then I can just square root both sides. So I'm going to have a plus or minus square root of -4. Since there's a negative in there, I have to bring out an I. So that's plus or minus 2i. So negative 3 plus or minus 2i, that's all right here with q. So cross off the only q that they gave us. All right, lucky number 7. Let's see what this one has for us. So things have gotten a little bit more intense. Now we have an x to the 4th power, so potentially 4 different answers for this one. On the bright side, if you look closely at this polynomial, all of the terms have an x in them, which means we can actually make our lives much easier by factoring an x out in the very beginning. So that knocks down all the exponents by 1. So we have x cubed, 6x squared, 11x to the 1st, and just 6. Next up, I'm going to use rational roots method on this polynomial in here. So my possible rational roots, just for this x cubed part, we've got 1, of course, we always have that, and then this is just factors of 6, so we have 2, 3, and 6. And let's plug those into the calculator. So on my calculator, what I put in my y1 was just this x cubed part of my polynomial. I don't need the whole thing. So let me go to my table again. Let's try 1 out, like I always do. That gave me 24, so no good. Let's try negative 1. And that gives me 0. Nice. So writing out my coefficients after I write down my results there, we've got 1 for the x cubed, 6 for the x squared, and then 11 and 6. Box number of negative 1. So bring down the 1 times negative 1 gives me negative 1, plus 6 is 5, times negative 1 is negative 5, plus 11 is 6, times negative 1 is negative 6. Plus 6 gives me 0. So I have the x that I took out initially. This factor here is going to be an x plus 1, x minus negative 1. And then my quotient, 1x squared, because we started with x cubed when we did this, and then plus 5x plus 6. Let's keep factoring. We got x, x plus 1, and now I need things that multiply to 6 and add up to 5. That would be 2 and 3. So x plus 2, x plus 3. Zeroing out all of these, starting on the left, we've got x equals 0, negative 1, negative 2, and negative 3. And those 4 answers are where? Right here, w. So let's cross off this w. But wait, there's another w over here, so we actually get to cross off 2 for the price of 1. Excellent. All right, it's final problem. Let's give this one a shot. Now we have another x to the 4th here, so that's again going to be a little bit more work. Unfortunately, unlike number 7, not all of the terms here have x's, so I can't just kind of cheap out in the beginning and take an x out to make it like one of the other problems. We are going to use rational roots though, and the good news is we do not have a lead coefficient that's something other than 1, so I can just look at factors of my constant. So we've got 1, 2, 3, and 6. We've used 6 quite a lot. Let me start plugging those into this on my calculator. So here's my y equals on the calculator. I've entered this whole x to the 4th thing in there. Going to second table, let's try out a 1. That gives me 0. Wow, first thing right off the bat. That's nice. So we've got our coefficients of 1, 1, negative 7, negative 1, a lot of 1s here, and then 6, box number of just 1. So bring down the 1. 1 times 1 is 1, plus 1 is 2, times 1 is 2, plus negative 7 is negative 5, times 1 is negative 5, plus negative 1 is negative 6, times 1 is negative 6, plus 6 is 0. Excellent. So at this point, I could rewrite all of this, but I'm going to have to go again because the ratio of these coefficients of my quotient, which would be x cubed plus 2x squared minus 5x minus 6, we're not going to be able to use grouping on this or anything else. So the good news is taking a look at the constant term, which is this negative 6, that's what this represents. Factors of negative 6 are still the same as the factors of positive 6. We still have plus or minus 1, 2, 3, and 6. So we have the same possible rational roots list, just using that on a smaller polynomial now. Let me go back to the calculator and enter this in. So I'll show you actually entering this one in here so you can at least see it written somewhere. I cleared out the x to the fourth thing that I had in there before. I'm going to forget all about that now. So I've got x to the third plus 2x squared minus 5x minus 6. So that's what I'm going to be plugging things into now. Now when I do this, I don't have to try out anything that I already tried on this larger thing that failed. Things that I tried on this that worked, however, like 1, I am going to have to try again, because it is possible that I have a double root, and I won't know that unless I try it again on the smaller version of this polynomial. So let me try one more time. That gives me negative 8 this time around, so that's not a double root. So let me go on to negative 1 then, which does give me 0. So I didn't have to search too far. 1 didn't work, but negative 1 did. So I'm going to use my coefficients right here. It's already written out for me. Now I'm just going to put in a box number of negative 1. So bring down the 1 times negative 1 is negative 1 plus 2 is 1 times negative 1 is 0. Or no, negative 1 rather. And then negative 5 plus that gives me negative 6. I was thinking ahead here. This is positive 6 here, and that's 0. Okay, so I just skipped ahead a few steps. Got to go step by step here. So now we've got the x minus 1 from that first root we found, x minus negative 1, so x plus 1, and then this is x squared plus x minus 6. So I'll keep these two factors that I got initially, and here I need factors of negative 6 that add up to 1. Positive 3 and negative 2 I think will work. So x minus 2, x plus 3. Zeroing all of this out, we have x equals positive 1, negative 1, positive 2, negative 3. And all of that is in this answer choice here. We've got the negative 3, the negative 1, the 1, and the 2 just written in order. So that's an S getting crossed off right there. And at long last, we've crossed off all the letters we could. It's time to solve the riddle, what do skeletons say before dinner? So we have a B-O-N-E, that's clearly bone. And then A-P-P-A-T-I-T-E, that's appetite, so bon appetit. Ha ha. All right, till next time, Mr. Sutton signing off.